So for the BC 2008 exam, we're going to take a look at the quicks first. So I look at a problem that's going to take about 30 seconds to a minute to solve. And looking at problem number 1, they give us the velocity vector. And then they want us to find acceleration, which is the derivative of velocity at time is equal to 3. So acceleration is just the derivative of velocity, which is 2t, comma 5, and then just substituting in the value of 3, which gets 6, comma 5, so that's letter B. So then we find our next quick, which looking at problem number 2, looks like a quick u substitution. So I'm going to let u equal x squared, so the derivative is going to be 2x dx, and so 1/2 du is x dx. Replacing in the problem then is going to read 1/2 the integral of e to the u du. Then anti-deriving e to the u is just e to the u plus c, replacing in that value of u. So looking at the problem, and I can see 1/2 e to the x squared is letter A, so that's another quick. So problem 3 looks like another quick as well. Looks like we're going to do L'Hopital, because the substituting in 0 for the numerator is 0, and then the denominator is 0. So we got the limit as x goes to 0, and it's going to be a product rule for the numerator, so g f prime plus f g prime. Okay, and deriving x is going to be 1. Then replacing in the value of 0, cosine of 0 is going to be 1. Cosine of 0 again is 1. And then sine of 0 is 0. So we've got 1 over 1, which is just 1, which is letter C. So problem number 5 is another quick one where it asks us to do the length of the path of the curve, but those are parametric equations, so I'm going to need the length, the integral, that's square root of dx dt squared and dy dt squared. So x was given as sine of t cubed, derivative of that's going to be 3t squared times the cosine of t cubed, and all of that is getting squared, plus derivative of e to the 5t is going to be 5e to the t, and again, all that's getting squared. This is going to be the integral from 0 to pi. So I'm going to start looking at my choices. They all go from 0 to pi. The only problem, though, that has that 3t squared squared in it, not A, not B, and I see that right there in C. So I'm going to grab that answer, and that's a quick. So I look at problem number 8, and it looks like a lot of words, but I can find the key word of doing a left Riemann sum. So I just need the widths of those rectangles. And coming from the left side then, so delta x is going to be 1, and then coming from the left side is going to be 6. And then delta x is going to be 2, and again from the left side, so negative 2. And delta x is going to be 3, and then coming from that left side, we're going to use negative 1. And then delta x is 5, and again coming from the left side is going to be 3. So totaling that all up, we get 14. Okay, problem number 5 looks like a straightforward second derivative, so I'll go ahead and get the first derivative, which following chain rule would be 1 over x, and then the derivative outside. So simplifying the problem, we've got 2 natural log of x over x. So doing a quotient rule, we've got low d high minus high d low over low squared. So that's x times 1 over x minus natural log of x times 1 all over x squared. So I'm substituting in the square root of e. It's going to be 1 minus the natural log of the square root of e over the square root of e squared, which then is going to get us 2 times 1 minus 1/2 over e. So that simplifies to make 1 over e, which is letter A. Then number 17 is another quick one. We're looking for the derivative at 2, so doing a chain rule. So f prime of x is going to be derivative of the inside, which is 2x, multiplied by the derivative of the outside, which is h prime of x squared minus 3, replacing then in the value of 2, which would be 4 times h prime of 4 minus 3, so that's going to be 4h prime of 1, which is letter B. And the last one that looked quick was the sum of the series, and it looks like it's a complicated problem, but I recognize that as the function e to the x, and they're just replacing in the value of natural log of 2 for every x, so e to the natural log of 2, which simplifies to 2.